You know that feeling you're staring at an exam question and just know there are marks hiding in plain sight? Well, today we're going to hunt them down. We're deconstructing a real physics question about, of all things, a hair straightener. And by the end of this, you'll see exactly how to bag every single one of those marks. All right, let's get right into it. The question we're tackling today is from a real AQA GCSE Physics paper, the higher tier from June 2022. So yeah, this isn't some made-up textbook problem. This is the real deal. Let's figure out the best way to attack it. So get this. The whole question is worth a whopping 9 marks. I mean, that's almost 10% of the entire paper, all wrapped up in this one little circuit diagram. So here's the challenge for you. Can you spot where all 9 of those marks are hiding? Let's find out together. Okay, part 1. First up, we've got a 1-mark question. This is a straight-up test of your memory. A quick, easy win if you've got your symbols down. The question asks for something pretty simple. Draw the standard circuit symbol for a light-emitting diode, an LED. This is one of those absolute basics you've just got to have locked in your brain. So what does a perfect 1-mark answer actually look like? And here it is. This is what the examiner wants to see. There are really 3 key parts to get this mark. You need the basic diode symbol, that triangle pointing at a line. You need the circle around the whole thing, and then this is the bit that catches so many people out. You need those 2 little arrows pointing away from it. That's what shows it's emitting light. If you forget those arrows, you lose the mark. Simple as that. All right, on to the next part. Now we're moving away from just remembering stuff. This is about applying a really fundamental idea about how circuits actually work. So the question gives us a little scenario. You close switch S2, but nothing happens. The LED doesn't light up. So why not? It's basically a little logic puzzle. Before I show you the answer, just take a second. What's the one thing every single circuit absolutely needs to work? So the key thing here, and it's true for any circuit, is that electricity needs a complete path, a closed loop to flow. And the mark scheme is actually pretty flexible here. You could say there's a gap in the circuit, and you'd get the mark. Or you could be more specific and say that switch S1 must also be closed. Either way, you're showing you get the big idea. Okay, time to crunch some numbers. Now, this is where showing you're working is absolutely crucial. Seriously, in physics questions like this, your method, how you get to the answer, can be worth just as many marks as the final number. The very first step for any calculation question, write down the formula. For this one, we're linking power, energy, and time, so we need this equation right here. You can pull it straight from your equation sheet. And you know what? Just writing it down often bags you the first mark. It's a no-brainer. But wait, hold on a second. Before you start plugging numbers in, you have to stop and check the units. This is such a classic exam trap. See how the energy is given in kilojoules? Well, our formula needs joules, so that 3.6 kilojoules has to become 3,600 joules. So many people lose a mark right here, so don't let it be you. And here's how you lay it all out to guarantee you get every single mark. Step 1, write the equation. Step 2, substitute the numbers in, our 3,600 joules and the 120 watts. Step 3, show how you rearrange the formula to find T. And finally, step 4, your answer, 30 seconds. If you follow those steps, you literally can't go wrong. All right, let's tackle the final part of the question. And this is a big one. It's worth 3 marks. This isn't a calculation. It's all about understanding the concepts behind parallel circuits. It's a chain of cause and effect. So what are they asking for? It's a 3-part explanation. We close more switches. So first, what happens to the total resistance? Then, what does that do to the current? And finally, what's the knock-on effect for the power output? It's like a chain reaction. Okay, let's build this argument step by step. The very first thing that happens is simple. When you close more switches, you're literally just adding more pathways for the current to flow through. A good way to think about it is like opening more checkouts in a supermarket. The more lanes you have open, the easier it is for people to get through, right? It's the same for electrons in a circuit. More paths make it easier for the charge to flow, which means the total resistance of the circuit decreases. Okay, so what happens next? If the resistance goes down, what's the consequence? Well, this is where Ohm's law comes in. The voltage from the supply isn't changing. So if you lower the resistance, the only thing that can happen to balance it all out is that the total current flowing has to increase. And that brings us to the final piece of the puzzle. Power is directly linked to current. So if the current has increased, it's pretty simple. The power output has to increase too. And in real-world terms, the air straighteners just get hotter. See how each step leads logically to the next? Boom, boom, boom. So there you have it. We found all 9 marks. But let's zoom out a bit. What's the big takeaway here? What are the key techniques we just used that you can apply to pretty much any physics exam question? When it comes down to it, doing well in these exams is about 2 things: knowing your stuff and knowing how to show you know your stuff. It's not enough to just have the formulas in your head. You've got to communicate your thinking clearly. That means showing your calculations, using those important keywords like increases or decreases, and building your explanations in a logical, step-by-step way. And that's a wrap. But hey, before you go, here's something to think about. Everything we just talked about, parallel circuits, power, resistance, we applied it to a hair straightener. But those principles are everywhere. So could you use that same logic to explain how a toaster works? Or a kettle? Or even the lights in your room? Getting your brain to think like that, that's how you get ready for whatever they throw at you next.